So this is the mechanics multiple choice part 2. We're going to continue. So a car wheel nut can be loosened by applying a force of 200 newtons on the end of a bar of length 0.8 meters as in X. A car mechanic is capable of applying forces of 500 newtons simultaneously in opposite directions. What is the minimum length L of the wrench which would be needed for him to loosen the nut? So what we should do is figure out the turning effect of bar X, which is simply 200 newtons multiplied by 0.8 meters. So 200 times 0.8 is 160 newton meters. Then we just simply apply this same number to Y. So the turning effect is force times distance. So the turning effect is 160 equals the force, which would be 500 newtons, times D. So D would be 160 divided by 500. So 160 divided by 500 is 0.32, which is B. So question 11 next. Two forces of 6 and 10 act on a point. Which of the following could not be the magnitude of the result? So when you get these types of questions, you just need to find out what the minimum and the maximum are. So the maximum possible would be if these two forces were acting in the same direction. So we would simply have 10 plus 6, which would be 16 newtons. And the smallest force is if they were acting in opposite directions, would be 10, take away 6, which would be 4 newtons. Then if you could imagine, we could have any type of combination at different angles that would give us any answer between 4 and 16. So normally in this type of question, what you have to do is look for a value that isn't in that range, and the only one that isn't is obviously the 3 newtons. So the answer is D. It will be impossible to get 3 newtons with the 4 and the 16. So let's move on to the next one. Question 12. So this is pretty straightforward. Two vertical copper wires, X and Y, of equal length, are joined as shown. Y is a greater diameter than X. A weight W is hung from the lower end of Y. Now, when they're in series, such as this, wire X and wire Y, with the weight at the bottom, the amount of force or tension that's experienced in each wire would be identical. So this is very straightforward. Which of the following is correct would be C. The tension in Y is the same as that in X. So the answer would be C. Whenever they're in series next to each other, they'll experience the same force. Number 13. So this is just some simple recall. Which of these is a scalar quantity? So if you remember that a scalar is simply a quantity that has magnitude only, and magnitude just means size. And the next thing instead of scalar would be a vector, and a vector has magnitude, which is size, plus direction. Momentum is a vector. Weight is also a vector. A moment is also a vector. Power, which is energy over time, or work done over time, is the scalar quantity. So next is question 14. The diagram shows how the stress varies with strain for metal specimens X and Y, which are different. Both specimens were stretched until they broke. Which of the following is incorrect? So the first one says X is stiffer than Y. It's above Y, so that is actually correct. B, X has a higher value of the Young's modulus. Young's modulus, if you remember, is stress over strain. And this is a stress over strain graph. So the steeper the gradient, the higher the value of Young's modulus, and X does have a steeper gradient, therefore that is correct as well. Let's have a look at D. Y has a lower maximum tensile stress than X. Maximum tensile stress is the highest value of the stress, and Y is indeed lower than its counterpart X. So D is also correct. X is more brittle than Y. Looking at these graphs, the more brittle material is definitely Y, as in the original question. It says that both specimens are stretched until they broke. Y breaks without warning, which would indicate that it is a brittle material. Could be glass. X has this stretchy part here as it goes into a plastic region. If you remember from your lessons, this will be the elastic region. And as it starts to deform, the curve up, this will be the plastic region. So X is definitely not brittle. It's something that's got some slight ductility. So C is incorrect. So question 15, a load of 3 newtons is attached to a spring of negligible mass and spring constant 15 newtons per meter. What is the energy stored in the spring? So what we can do is calculate the extension using force is equal to K times E. So the extension will be the force divided by the spring constant, so that will be 3 divided by 15. Which gives 0.2 meters. Then to get the energy stored in the spring, we can simply do energy is equal to half K E squared. So put our numbers in, so it's 0.5 times K, which is 15, times the extension squared, so 0.2 squared. Which would give 0.3 joules, which would give us an answer A. So let's get rid of that one. Now we had a similar question earlier on in the booklet. A body falls freely with negligible air resistance. What quantity of the body is its rate of change of momentum? So the rate of change of momentum, rate of, remember, just means divide by time. So we're going to divide our quantity, which is momentum, by time. So force is equal to the change in momentum divided by the change in time, which is measured in newtons. And then we just need to look at which of these quantities is equivalent to Newton. So mass is measured in kilograms, power is in watts or joules per second, kinetic energy is in joules, weight is in newtons. So the answer is D. Again, a similar question, just dressed up differently. Which of the following statements is correct? The force acting on an object is equivalent to A, its rate of change of momentum, or its change of momentum, sorry. B, the impulse it receives per second. C, the energy it gains per second. D, its acceleration per meter. So what we should look at is, now if we write force is equal to change in momentum over change in time, you should know from lesson that the change in momentum is equal to force times time. And this quantity is also known, and this quantity is known as impulse. So we can safely say that the change in momentum is impulse. So impulse it receives per second, impulse per second would be equivalent to the force. Let's look at question 18 next. So a car accelerates uniformly from rest along a straight road. Which graph shows the variation of displacement x of the car with time t? So the displacement of the car. Now the equation on your data sheet would be s equals ut plus a half at squared. Now the question, it says that it's from rest, so you would go. So we'd be left with s equals a half at squared. And what we need to do is just to change the s with displacement x, as it says in the question. So x is equal to a half at squared. Because the car is accelerating uniformly, acceleration will be a constant, so the relationship that is remaining will be x is proportional to t squared. And if you look at that, it's very similar to, or it's the same as a y equals x squared, or y proportional to x squared graph. And the graph that looks like a y equals x squared would be graph B. And I could just show you that if you extended that, you would get the traditional y equals x squared graphical expression. So the answer is definitely B. Let's move on. So question 19, which of the following is not a unit of power? So this is some dimensional analysis and some equation playing about with the units. So the first one, Newton meters per second. Well, we know that Newton meter, we know that work done is force times distance. So work done can be expressed as the Newton meter. So obviously work per second, or Newton meters per second, would be power. So that is actually correct. The second one is, this is more complicated, part B. So we know that power is energy over time. And we know that energy is work done, which is force times distance. So we could say that would be equal to force times distance over time. Force is Newton's second law, so F could be equal to ma. So power is ma d times distance divided by time. And then we just need to put our units in. So power will be equal to mass, which is kilograms, acceleration, which is meters per second squared, times distance, which is meters, divided by time, which is another s to the minus 1. So the total one is kilogram, a meters squared, s to the minus 3. So B is also correct. C is just power is energy divided by time, joules per second. So that's also correct. So the one that must be wrong is D. So let's move on to question 20. So for question 20, we should have a read and then label the diagram. A lift and its passengers with a total mass of 500 kilograms accelerates upwards at 2 meters per second squared as shown. Assume that G equals 10. What is the tension in the cable? So the tension in the cable is going up. The weight of the lift and the passengers is mg. And then we can just do the sum of the forces is equal to ma. So the sum of the forces would take up as positive as the lift is travelling upwards or accelerating upwards. Sum of the forces would be T minus mg. The reason it's minus mg is because it's going down compared to our positive direction of up. And that will be equal to ma. Then all we need to do is rearrange to find T. So T is equal to ma plus mg. And we can factorise this just to tidy it up. Ma plus g. So tension would be the mass, which is 500, times A plus G. A is 10. Sorry, A is 2 and G is 10, which would be 500 times 12. And that will give us 6,000 newtons. So the answer is D.